Example number 2. Let's see, we've got 6 secant theta tangent theta equals 3 over 1 minus sine theta minus 3 over 1 plus sine theta. Ooh, that's got a lot of crazy stuff in it. Solving suggestion. The right side is the more complicated side in this equation. So we start with the right side, performing the indicated algebraic operation and applying identities. So what algebraic operation is being inferred on the right side? We have a fraction minus a fraction, right? So what is that basically saying we need to do? We need to combine those fractions, right? But we can't do that without a common denominator. It's already lagging. My favorite thing. Yay. Okay. Combine our fractions together. So we need a common denominator. So we need to get common denominator first. This really isn't going to let me write. Guess I'm just trying to go too fast. Slow down and we're good. My computer's just trying to tell me what my students have been telling me for ages. Okay, so what would the common denominator be for 1 minus sine theta and 1 plus sine theta? Honestly, it would be both of them multiplied together. It would be 1 minus sine theta times 1 plus sine theta. Just because they both have a 1 and they both have a sine theta in it doesn't mean that those are the same number. This is one number completely different than this number. Like if I needed to add 1/3 and 1/4 together, 3 and 4 are completely different numbers. I would need to multiply those together to get my common denominator, right? And so then I would have a 4 plus a 3, so I'd have 7/12. 3 and 4, completely different numbers, would need multiplied to get that denominator. Same idea here. 1 minus sine theta and 1 plus sine theta are two completely different numbers because sine theta represents some decimal for some angle, and subtracting that from 1 and adding that to 1 is two completely different things. Okay, so hopefully that makes sense that we need to actually multiply them to get that common denominator. Sorry if you were writing down my hint. I just did away with it so it didn't complicate my screen. Okay, so what we need to do to get our common denominator here is actually multiply the top and the bottom by 1 plus sine theta on our first fraction. And then on our second fraction, we're going to multiply by the other denominator. And now we're going to simplify by adding those fractions together. Okay, I guess I should distribute first, maybe. So I'm going to do the distributive property. You can make a note as to what you're doing in each step if you think it would be good to justify your answers. I would always recommend that you do that if you can on a test. I don't remember how we tested on these last year because the test came after COVID started. So then we had to figure out how to test identity stuff. It was interesting. Okay, so then we'll have 3 times 1 is 3, plus sine theta will be 3 sine theta. So I distributed that parentheses. Now my second set of parentheses, I'm subtracting this fraction, so I'm just going to call that a -3. So that would be negative 3 times 1, so minus 3. And then a negative 3 times a negative sine theta would be a positive 3 sine theta. So I can distribute and then combine, right? Do you guys mind if I keep kind of putting this all in one line, even though it's just I'm combining them together? So what happens to my 3 and negative 3? And now I add my 3 sine theta and my 3 sine theta, which is just like terms. 3 and 3 is 6. So the sine theta just goes along with it. Now I ignored the denominator there for a minute, so let's look at our denominator. What happens when we multiply 1 minus sine theta times 1 plus sine theta? I don't know if you noticed, but those are conjugates. It's a conjugate pair. So 1 times 1 is 1. And then 1 times sine theta is sine theta. And 1 times negative sine theta is negative sine theta. And then negative sine theta times positive sine theta is negative sine squared theta. So that those canceled, and now these two cancel. And we have 1 minus sine squared theta. Okay, just a big hint. Anytime you see squareds in your problems, look at the Pythagorean identities. Let's go back. Let's look at them really fast. Do you see anything that could be significant in this case? There's a 1 minus sine squared right there. What's it equal to? Cosine squared. Now, we wouldn't want to just go ahead and switch that out unless there's a reason for doing it. So keep in mind what's on the left side. This whole time while you're working on the right side, you should kind of be keeping this part in your head. Look at what we've got so far. We have a 6. That's good. But right now, all we have is sines, and we need a secant and a tangent. Is changing this to a cosine going to somehow help us get to there? Let's see if that will or not. So we're going to do a Pythagorean identity substitution. Sometimes I start getting lazy with what I'm writing out. Pythagorean substitution. So by that, what I mean is I'm replacing my 1 minus sine squared theta with cosine squared theta, because that is equivalent according to our Pythagorean identities, right? This equals that. So I just did a Pythagorean substitution. Cosine squared, doesn't that mean 2 of them multiplying together? So technically, couldn't cosine squared be rewritten as cosine times cosine? Do you see what's going to happen? Anybody want to tell me about it? We still have a 6. But now, because we have it over a cosine, there's kind of an unwritten, unspoken 1 in there. 1 over cosine. What can we say that is? 1 over cosine is... Why does my 6 look more like a B? I hate 6's and B's. They look too much alike. Okay, so 1 over cosine is secant. And then we have this part here, sine over cosine, which is tangent. You see what just happened? That is our left-hand side. If you need me to, I can write this out a little better so you can see what just happened. So we've got like a 6 And we've got a sine. So this part right here is our tangent, right? And we could do 6 times 1 times sine. So that part right there is our secant. And then the 6 is just multiplying. It just carries along for the ride.